And this software will also run in a sort of demo mode for data acquisition purposes. So this is how we take data. So I've got load and unload buttons and some wafer handling ones. A simple move around the stage button here. I can just double click and send it wherever, or type in a position. I'm in an R theta coordinate system. I can switch that to an XY if you'd rather. And I've got buttons to move it around. I can select which laser I'm using. I can run a recipe, which is a predetermined set of measurement parameters. My single spectrum window will bring up my spectral acquisition. I set parameters down here for wavelength. In this case, this is configured to be a grating that doesn't move, so it's fixed at 765.6.5, and it measures then 200 to 1333, which is a frankly unlikely thing. So that's very coarse resolution at 4 nanometers, but it's not real data because there's no instrument connected to this. So I get a peak that looks like this. I could tinker with those parameters to change them. Really, my intensity control here is my slit width and the speed of acquisition. And I can select a filter from the list here. And this is not a mapping mode, so I'll close this one out. This is our spectral mapping mode, which is the same window with the addition of mapping parameters where we can set a wafer size. If we've got a 3-inch wafer to do a 76mm scan diameter, our scan time, acquisition time for the detector that's configured in this software, that's limited to 15 data points per second in this save everything mode. With the detectors we've discussed, that will be limited to 30 points per second. So a 3-inch map will take us about 2.5 minutes, 5 minutes in this case. I'm going to do a much smaller map. I'll do, say, 25 millimeters. Well, let's do 20 millimeters. We're down to 29 seconds then. It requires me to take a sample spectrum first, and then I can start mapping. I'll move the stage to the home position. Ask me for a wafer ID. I'll choose something cryptic like test. I can enter an operator name if I wish. All of these fields are non-mandatory apart from a file name. Me. I'm setting the material to gallium arsenide. That really doesn't make any difference to PL measurements, but for some of the reflective measurements, you need a refractive index to calculate a thickness, for example. So I'll move to the right place, and well, it all happens very quickly because there's no real instrument attached. So I've got the same thing, and again, I can double click and view what have I got. Okay, so it's exactly the same everywhere, and somehow we have a non-zero standard deviation in that one, but most of the rest are set. Oh, and yeah, then it's automatically saved the data in the process of acquiring it, so there's no need to do any more. So if your recipe creates a report file, then your database can automatically grab that from your machine, and your data goes in automatically.